Hello, my name is Jenna Weiser, and I'm going to be going over my scope of work for the Clovis Unified School District 8 campus kitchen HVAC replacement that I did with New England Sheet Metal and Mechanical, focusing on the HVAC and plumbing scope. So, getting into our table of contents, I'm going to try and run through these as quickly as possible because I know it's a lot to cover. So, first we have the introduction of our project. Um, we're going to get into the project description, the project scope. I'll discuss the means and the methods of how we executed the project. I'll discuss a little bit about the different materials we used in our scope, and then touch on some of the equipment that we projected to use, continued by the sequence of work that would take place, and then an overview of how we would estimate the costs for the project, give a quick overview of the schedule for the project, and then discuss a few key safety elements that we consider when performing this scope of work, and then also touch on some quality control and assurance measures that we have in place. And then I will touch on the conclusion of the assignment. So, my name is Jenna Weiser. I am working for New England Sheet Metal right now as a estimation intern. I am currently a CSU Fresno state student, and I'm in the Masters of Construction Management program, and I will be graduating this spring. This is my final course. So, looking at the project, a brief description of the Clovis Unified 8 campus remodel was it was, I believe it was 7 elementary schools and 1 high school, and we were going to be primarily renovating kitchens and the HVAC systems of the kitchens. The project, um, we were going to be bidding as a prime contractor for the project. And each campus had varying levels of involvement. Some of them, the replacement was pretty straightforward. Others, we were removing existing ducting or there was abatement, which is not a part of our scope necessarily, but um, depending on what was existing, dictated a lot, and the depth to which our scope got involved. So looking at the project scope that New England would be self-performing, it would be the HVAC and then the mechanical piping, as well as some plumbing. That is our full scope. I'm focusing on the HVAC and mechanical piping. Um, these are not pictures necessarily from my project, but I did just want to show a picture of some larger mechanical or HVAC equipment being installed um, on a roof. And then this is what the piping, refrigerant piping, and then the hot and cold water return, and possibly even gas. There were some gas lines as well on this project as well. So the means and methods for this project, like I said, varied because each campus was unique. And even though the project was looking at 8 campuses as a whole, because they were individual campuses, the work was going to have to be tailored per campus. Um, that being said, also, because it was set as one project, all of the work was more or less set to commence simultaneously during the summer break. Um, and so the means and methods for how the project would be completed would be to start with the demo, if abatement was needed, handle the abatement, and then the any concrete pouring, so housekeeping pads, if there had been concrete removal, possibly patchback. And then once the concrete cured and we got confirmation of that, then we would be able to start performing our scope. So here is a picture of so in this project, we had a couple of campuses that had mechanical yards, which I don't have any pictures from our projects because the pictures that we could get, we only did a job walk at one campus, and it wasn't one of the mechanical yards, so I don't have a picture of that. But this is a picture of what a unit would look like on a housekeeping pad, which is this concrete pad that would need to be poured and cured before we could set our um, air conditioning unit in place. So all of these conditions are things you have to take into account when planning which units. And then this is a unit, again, not from our specific project, but very similar to one of the schools. Most of the time, not all the time, but most of the time, um, rooftop units will be put on a flat portion of the roof, even if there is pitched portions of the roof, usually where the mechanical equipment is placed or in the drawings, the roof will be flat. But like I said, not in all cases. This was one of the cases where the roof was pitched. We would have had to we would have had to place a curb and have supports, similarly to how this picture shows. So that's just a couple of the means and methods of how we would have had to install different equipment. Looking at some of the materials we would have we use when performing our scope. So first we have ducting. Um, this is planned by the architect and the engineer, so it depends and varies widely per job. And in this instance, because there were 8 campuses, some of them had exclusively rectangular ducting, some of them had round, some of them had both. So it really just depends because this project we were often tying into existing ducting, the conditions would change per school. So whatever the um, original ducting was is often what would be taken into account. So you have round ducting, you have rectangular, you have flexible and rigid. So there's many types for the different applications within the whatever project you're working on. And in this case, like I said, it did vary. Um, and then next we have our mechanical piping. So in order for the units to cool uh, as an air conditioner would, you have to have some way for the units so the units push air past typically a fan coil, and that fan coil has to drop in temperature in order for the air moving across it to be cooled. Um, that can happen several different ways. It can either be the piping can be filled with refrigerant, um, which drops the temperature. It could be hydronic, so using hot water, cold water, depending on whether you're heating or cooling the space. You could also use gas piping if you're heating if it's like on a unit that heats and cools. Gas piping would be the heating element for that. And then we also have condensate piping because whenever you have change in temperatures, you're going to have condensation and you have to account for that and have a way for that to drain so that it doesn't pool and create leakage or, damage to surrounding areas. So another key material is insulation. And while the insulation itself, we typically subcontract this out, um, especially on larger projects like this. It is an integral part of our scope, which is why I listed it, even though we don't typically, um, it's not we can supply it. It's just not something we typically handle because it's easier for someone who specializes in installation to take care of it. But it is an integral part of our scope because it greatly affects the performance of the air conditioning systems, the piping systems, and just all of those supportive systems to one another. And then finally, we have our supports and our ancillary material, um, which sometimes are things we can just purchase, and sometimes are things we have to fabricate. Again, it varies per job. Regarding the 8 campuses, I believe some of them were just standard supports. Some of them were wall supports because we would have a ground mounted unit and the ducting would have to rise up the side of the wall and penetrate through the wall. So just all of those other parts and pieces that support the overall air conditioning system that are necessary to perform our scope. So looking at the equipment, these are just probably the top three that I would say we use. There's many other pieces of equipment that we use. The crane, we use probably hands down the most. It's the easiest for setting equipment, especially rooftop equipment, ground mounted equipment. The units are very large and very heavy, and so you just can't lift those physically. So the crane, again, something we subcontract, but because we don't have a license to use a crane, um, but it is necessary for our scope. And then scissor lift and forklift, these are two pieces of equipment we often have. We rent and we keep them on site for the duration of projects. Um, so moving on to sequence of work. So, in order for us to perform our scope, there are a few steps that have to happen before. So, I think I mentioned earlier, first we would need demo to take place to remove all of the old ducting, old equipment. We can perform this, but because of the size of projects, especially this 8 campus Clovis Unified job, we were subbing that out because it was much easier for the manpower to have somebody, a subcontractor, take care of this. And then the abatement, we would not have been able to do ourselves. So again, a subcontractor would have to take care of that. And then once you remove all of the old stuff, then any concrete that needs to either be patched back or housekeeping pads. Sometimes on the roof, you may have like a roof curb for a unit that might have some concrete. And so we have to have those put in place and cured before we can begin mounting and laying out and setting the equipment. But while the concrete is curing, we will oftentimes work on the plumbing, the piping, getting that if there's any underground piping or any piping that might be running from a first floor to a second floor or first floor to a roof, we'll start handling that while the concrete is curing. Then once the plumbing is installed, we will install any of the ducting that needs to be put in place. And then once all of that is in place, then we can hook up, we can set and lay out and hook up the equipment. Oftentimes it'll be anchored down to the concrete, so that will be close to one of the final steps. And then once the equipment's in place, then we can hook up any of our piping or any of our ducting to the equipment. So, in order to do cost estimation for a project, you first have to understand the full scope of the project, or as much of the full scope as you can. This is what I primarily work on doing currently in my internship, is the cost estimation. So I have learned a lot about this particular sequence in the in the bidding process. So first, understanding your scope and where it falls within the project. The second thing would be to upload your documents into whatever takeoff software. We use AutoBid Sheet Metal and AutoBid Mechanical for the piping, and AutoBid Sheet Metals for the HVAC. So start a new project in there, load in your documents that pertain to whatever takeoffs you need to do. Then the next step would be to perform your takeoffs, make sure you're capturing the materials you need, the insulation thicknesses, and all of that based on the plans and the specs. Then once you've completed the takeoff, you can run the report, which is going to generate your material costs, your labor, your fabrication and installation labor. And then you can use all of those numbers that are generated and input them into whatever workbooks. So we have different workbooks based on the different jobs and the different scopes that we're performing on a job. So in the 8 campus um, project, we did it a little bit differently because there were almost as if it was 8 separate projects all compiled to one. So there would have been a lot of workbooks to work through. So we ended up doing it a little bit differently for this project in particular, but still all the same processes, just a little more condensed. So we input the material quantities and costs, then we input the fabrication and installation hours, which generated our total labor hours. And then from there, we can reach out to our different vendors and for our equipment and our fixtures and our accessories, and we can reach out to subcontractors, which is how all of that would be compiled. And for a singular scope, um, as if we were bidding as a subcontractor, there would still be certain things that we couldn't perform, like testing and balancing. We always have to subcontract that out. Controls, we would always have to subcontract that out, unless it's a really small project. But most of the time, we're going to subcontract that. So we would input our quotes from our vendors once we receive them. And then the final step is looking over and based on our labor hours, accounting for proper supervision on the sites, looking at our general conditions and seeing like what we might need, whether we're going to need an on-site trailer, whether we're going to need any temporary facilities. We capture office supplies and any miscellaneous things in our general conditions. And then finally, we look to see what equipment rental we might need on that particular job for that particular scope. And then that total cost is what our bid package and bid price would be. So looking at project scheduling, we start with this by looking at long lead items. So oftentimes it's going to be our bigger air handling units, our bigger uh, package units, things that are larger equipment pieces will typically take longer. Not always, but it can vary from a couple of weeks up to 16 weeks, which if your project is supposed to be starting in 2 months, could be a big issue. Um, another thing that we had on a recent project, um, different than this project, but we tanks had 16-week lead times. Pumps had 12-week lead times. So we always want to start when we're looking at the project schedule with long lead items, and then those are typically the driving critical path for the project. So then once you have that dialed in and you know what is going to be your uh, driving force for the project, you can figure out how long the project is estimated to take based on that, and then other um, information. For example, uh, total labor hours uh, will dictate your duration. And then if you have a projected notice to proceed, then you can figure that all in from the start of the project, based on the start of the project. So with the way we do our estimations, we are given the total labor hours. The total labor hours drives the crew size. Um, Also based on the project duration. So if the project duration the owner needs the project duration to be a shorter amount of time, then we're going to have larger crew sizes to be able to accommodate that. But based off of our labor hours is how we project our crew sizes. And then based off of our crew sizes dictates how many numbers of crew days the project should take. So looking at some key safety elements, when we are looking at HVAC and plumbing, we always want to take into account the safety of our workers um, and the surrounding area, because we use large pieces of equipment, particularly the air handling units, makeup units, package units, and those oftentimes, like I said earlier, need a crane to lift and set them. We want to make sure that we're taking into account all of these different factors when looking at a site. This particular job site in the Clovis Unified Schools was the only campus that had a rooftop unit that was on a pitched roof. This is, I think I showed a picture earlier, and this was kind of that same idea where this is a rooftop unit and you have to take into account the curbing of the unit and all of that. But in this particular case, because it is a pitched roof and there's no flat roof coming off of this campus in particular, we had to account for fall protection. So that in the event that a worker were to slip, fall, they would be safe. So, a couple things that we do within our HVAC and plumbing scope to ensure quality control and assurance measures is first off, we are signatory to the unions, to the sheet metal union and to the UA, the piping union. The reason that this drives quality control is because the gentlemen who are on site with our team performing most of the installation, they are trained very heavily. They often come with um, very extensive training from the union. And that also means that the union dictates their pricing, but for us, it is more than worth it because we know that the quality of their training and the workers that are going to show up are going to be knowledgeable and be able to perform the work well. And then another thing that we is a requirement on all jobs as a assurance measure is we have warranties and maintenance requirements per the documents and plans. It's typically, I think, 1 year maintenance, and the warranty, I believe, maybe for the life of the unit, but I could be wrong about that. So, all in all, as you can see, there are a lot of components that go into um, taking off a particular scope. So I hope that you learned something about the HVAC and plumbing scope, and I hope you have a good evening. Thank you.